This is Lab 1, Electric Force. The purpose of this lab is to determine the charge on a floating piece of clear tape that is feeling an electric force from another piece of charged tape. So in order to do this lab, you have to make some big assumptions. The first assumption is that the two pieces of tape are identical and have identical charge magnitudes. The two pieces of tape behave as point charges, and that there is no air resistance in this model. This allows us to use the point charge model, and you can use Coulomb's law in order to determine what the charge of a floating piece of tape is. So there's no momentum in this problem because there's no velocity of our tape. Nothing is moving. It's just the only forces are the gravitational force and the electric force. The main equation we use is the gravitational force is equal to kq squared over the magnitude of r squared, and we are able to use q squared because of the first assumption that the two pieces of tape are identical and they have identical charge magnitudes, so the charges are the same. Determining the charge of the tape, we determined that the tape is negatively charged because when you pulled the strip off the tape and you had two charged U strips, they repelled each other. The U strip was also attracted to my hand, which was neutral, and when the negative plastic pen was held up against it, then it would be repelled. My trusty lab assistant found that very true. So to set up our floating tape, the initial conditions were the length of the tape was 0.195 meters and the mass of the tape was 1.95 times 10 to the negative 4 kilograms. We positioned our tape B around the origin, and then the force of repulsion was felt around 0.023 meters, so our R vector is about 0.023 in the Y direction. This is my glow script. In order to predict the charge on tape B, we need to use the relationship the magnitude of force of gravity is equal to the magnitude of the electric force. This is the equation that I came up with when you assume that the magnitudes of these are equal. Something to note in my glow script, because the force of gravity and the force of electric are opposite, then you need to show that the signs are opposite. So while the magnitudes are the same, the electric force is equal to the negative force of gravity. So we are able to calculate our charge in this leveling model. The green arrow is the direction of R, the red arrow is the direction of the force of gravity, which is pointing in the negative Y direction, and the orange arrow is the direction of the electric force, which is pointing in the positive Y direction. The yellow ball is the point charge of tape B, and the blue ball is the point charge of tape A. And so we find that the magnitude of the electric force and the magnitude of the gravitational force are equal in magnitude, opposite in sign, and the magnitude of the charge of tape B is 1.06 times 10 to the negative 8. So now determining how the electron to atom ratio on our charged piece of tape, we are able to find the number of atoms on the tape by taking the length of the tape and dividing it by the length of an atom. The number of electrons on its piece of tape you can determine by taking the charge of the tape divided by the charge of an electron, and that gives us a ratio of about 34 electrons per atom. These also have some pretty large assumptions that the tape has only length, not width, not height. It's just one straight line, and all of the atoms are in a uniform straight line. So what if electrons had a positive charge and protons had a negative charge? What would change about observations? Well, if electrons had positive charges, then everything would be the same interactions. It would just be opposite. So the U tape would be positive, and the two charged tapes would still repel each other because it would be positive versus positive. The tapes would still be attracted to my hand because it would be positive versus neutral, and the charged pen would still repel the charged tape, positive versus positive. And then it's important to handle the charged tapes as little as possible because the tape will eventually become neutral as the electrons transfer between the tape and the object. The more you touch the tape, the more electrons are going to want to transfer over to the neutral object, and then everything will become neutral.